Now let's have a look at the question where we can use the partition technique we used in quicksort, where we have two pointers that are moved both of them are moving from the left to the right. So here we have an array. We need to write a function to move all the 0 elements to the end of the array. So this is very similar to the idea of partition, where we have remember in partition we have a pivot index, and all the elements on the left side of the pivot index are smaller than the pivot value, and all the elements on the right side of the pivot index are greater than the pivot value. So here, notice we have two pointers. One is the I, basically we loop through the array. Then we have a slow runner called pivot index. And notice the condition here. Instead of comparing the element's value and the pivot value, we just to see if the element is 0 or not. So we can illustrate here. Basically, we have an I index that's looping through from the left to the right. Then we have a pivot index. On the process of moving, if we encounter the 0, then we just so if we encounter the element that's not 0, so we just swap it with the pivot index. So remember in the quicksort, we guarantees all the elements that's in front of the pivot index are elements whose values are smaller than the pivot value. So here we just change the condition to guarantee that all the elements that are in front of the pivot index are non-zero elements. So what we do is as I loops through, when we encounter the 0 element, we swap with the index. First, in the beginning, they're all in the same place. So when we are swapping we are swapping the elements in the same index, which doesn't do anything. Then as I moves to the right, then we encountered 0 in this case. Then in this case, we don't swap. So the pivot index stays here. And then I moves through, I2. Now we swap the index, the 9, with the pivot index. Then gradually squeeze the zeros to the end of the array. So this is almost the same idea as the quicksort partition, but we just change the condition here.